questions G and H, it's asking us to construct some equations. So we need to make sure that we're looking at the formulae, and the formulae come from the page previous where we were given all of the diagrams. In G, it asks us about the complete combustion. If we're talking about complete combustion, we know that carbon dioxide and water are produced. So having CO2 and H2O would give you one of the 2 marks in this paper. The second mark comes from balancing, and because we've got 7 carbons here, 7 carbons here, we must have 7 carbons here, and once we've done that we then need to look at our hydrogens, 16 here, and therefore we need 8 here, and then working backwards we count our oxygens and we take it through to 11 on this side. For H, a hydrocarbon molecule is cracked to form an octane molecule and 2 molecules of butene. We take our structure C16H34, which is given to us in the question. We know it's cracked, so it's broken down. It tells us that it's forming an octane molecule. Oct the prefix for 8, and using the CnH2n plus 2 rule, because it's octane, we know that it's C8H18. We're also forming 2 molecules of butene, so this is an alkene and therefore CnH2n. But means 4, so we have C4H8 and we have 2 molecules of that. The next question is asking us about functional groups and then isomers. So this one here is asking us what is meant by the term functional group. This is key knowledge. It's a group of atoms that are responsible for the chemical properties and their reactions. That is just something to learn by rote, off by heart. The next question is asking us if compound I, and compound I is given to us above and also on the page previous, reacts with chlorine in the presence of UV radiation. It gives us several isomers of C8H17Cl. And then it's asking us how many structural isomers can be formed in this reaction. If we take our structure, which we are given to begin with, when the chlorine is added, and we know it's added because it's saying I reacts with chlorine in the presence of UV radiation, it means that the chlorine that's added can be added at lots of different places. It can be added at carbon 1, 2, 3, 4, 5, 6 or 7, and it could be added to the branch. So on the diagram here, I've just indicated all of the different points the chlorine could adjoin. 1, 2, 3, 4, 5, 6, 7, and also on the branch at this point here, 8. So there are 8 potential isomers that we could have if we were to chlorinate compound I in the presence of UV light. Last question here is about radicals. What is meant by the term radical? Radical is the presence of an unpaired electron. It's not acceptable to have any other way of saying this, so you can't say it's a lone electron or a single electron. It has to be an unpaired electron because it's the fact that it's not part of a pair that makes it the radical.